Ready? I'm going to bring everybody out in 2 seconds, but just a little bit of logistics. It's been 87 years since John Maynard Keynes wrote The Economic Possibilities of Our Grandchildren. He wrote about the relationship between economics and work, and of course he argued that technology displaces jobs but not work. And so we have this remarkable puzzle, and that makes me today a little bit like a tour guide at a Rorschach test. So a note about process. I'm going to bring out the speakers. I'm going to just introduce their names. I'm going to invite you to look at your program for their biographies. I also want to ask you to help me. If you will tweet questions, that's 140 characters, to hashtag MIT AI Jobs, I will do my best to weave your questions into our conversation, which are going to be short. And so then the only question is whether I can walk and chew gum at the same time. So if we can bring out our first panel, Erik Brynjolfsson, Kai-Fu Lee, James Manyika, and Mona Vernon. Yeah, actually Mona's at the far end. You sit at there, yeah, that's great. And why don't you, no, I'll take this one, you take that one. Yeah, and you're first.
So good morning, I'm Erik Brynjolfsson. I'm the director of the MIT Initiative on the Digital Economy, and the first thing I want to do is add my welcome to Rafael Reif's and Daniela Rus's. I'm so glad that you guys are all here. I see what we're doing as one of the biggest opportunities and one of the biggest challenges for our society, for our generation, maybe for all of history. And as you know, we have an amazing lineup of speakers, but I also want to underscore what John just said, that we want to engage all of you. So I encourage you to please go ahead and tweet your questions and ideas to that URL, hashtag MIT AI Jobs. And we'll do our best to incorporate those and collate those. So let me talk a little bit about this great challenge and opportunity that we have right now. And a fun way to start the conversation is just to ask a question, which is, what do you think were the most important events in all of human history? And this is a thing I sometimes do at dinner parties and discuss, and you get all sorts of interesting answers to this. People will say, they'll talk about the rise and fall of the Roman Empire, or the invention of paper 2,000 years ago in China, or the discovery of America, all sorts of different ideas. It's lively. And so I encourage you to do this one time and let the discussion run a little bit, and then show them this chart. And if you think about it, there are all these amazing things that happen through history, new religions, kings and emperors, Black Plague, but the living standards of the average person, the typical person, didn't really change all that much for thousands and thousands of years until the Industrial Revolution, until James Watt invented a better steam engine, until a bunch of people figured out ways of incorporating that into their mines, their factories, into their transportation systems, and all sorts of metrics of human progress all just started improving dramatically. And the reason that we today in this room and really around the world are tens or even hundreds of times wealthier than our ancestors a couple of hundred years ago is because of technology. And as Rafael said this morning, here at this Institute of Technology, we're very proud of the role that technology has played to lift so many people out of poverty. The technology that really triggered the Industrial Revolution was all about augmenting our muscles. The steam engine, later the electric dynamo, the internal combustion engine, they basically brought more and more power to us to be able to shift around the physical world. But we're now in the early stages of another transformation. Andrew McAfee and I call it the second machine age, where we're using technologies to augment not just our muscles, but our brains, allow us to control the world and figure things out more effectively. And this, I think, has at least as much potential as the first machine age, the one that augmented our muscles. For most of that period in this second machine age, the machines had to be told very explicitly what to do, what Yann LeCun was calling good old-fashioned AI and just traditional programming. And any of you guys who have coded, you know you have to be very precise when you code things. You have to write down in detailed descriptions of what you want the machine to do. We're now in a second wave of the second machine age, where machines are beginning to learn how to figure out how to solve problems on their own. Jan gave a bunch of great examples. One of the ones that really was an aha moment for me was when a team at Google DeepMind developed a system to play Atari video games, something I wasted much of my youth doing. Maybe some of you did as well. So I was impressed when they gave just the raw pixels of Atari video games to a machine, a reinforcement learning system, and they gave it 2 other pieces of information. They gave it the score, and they gave it a controller that could move around the thing. But they didn't explain the rules. They didn't even say what the objects were, that whether these pixels represented blocks or a ball or a paddle. And they just let it run. And giving it this raw information, what you saw was that at first, it sort of randomly just wiggled around the paddle, and sometimes would hit, sometimes wouldn't. But the reinforcement learning system taught it to try to more and more use it effectively. And so after about 300 games, the machine started getting to be pretty good, as good as I was when I was a teenager, hitting the ball most of the time and being very successful. And so it learned this entirely on its own without being hard-coded what strategies you're supposed to use. They let it run for another few hundred games, and it started figuring out new strategies that none of the programmers had figured out. For instance, it figured out how to send the ball around to the back of the thing there and get a lot more points. And the guys who wrote these reinforcement learning systems said they didn't even know you could do that strategy. That was something, obviously they hadn't spent enough time playing Breakout, but this is something that shows that a machine can learn on its own in remarkable ways. And these technologies now are being used not just to play video games, but to help cure cancer, to run data centers more effectively, and a whole host of other things we're going to hear about. We heard some this morning. We'll hear more in the rest of the conference. But this is a real milestone in human history, and machine history, I guess, because we are now able to have machines that figure out how to solve problems on their own and potentially do a lot of things that make us all much wealthier and healthier and better off. But before we get to the other panelists, I just want to leave one last point, and we've heard about this a little bit this morning as well, which is that it's not all roses and butterflies. While labor productivity is up and it's at record levels in the United States and around the world, other economic indicators aren't doing as well. Andy McAfee and I wrote an article called The Great Decoupling that described how many of these economic indicators that used to be tightly coupled for most of the past couple hundred years, rising median income, rising employment, have now become decoupled. And although productivity continues to grow, median income, the income of the person at the 50th percentile in the United States, is basically the same now as it was in the 1990s. So most people have not participated in this gains. But I agree with what Raphael said, that this is not a function necessarily of the technology. This is a function of how we use the technology. And we have different ways of deploying the technology in different kinds of institutions, different investments we can make in education that lead to different sets of outcomes. Ultimately, we can create more inclusive innovation and more broadly shared prosperity, but we have to take on these challenges, not just of making amazing technologies, but also changing the future of work in a way that everybody benefits. So let me leave it at that and turn it over to the other panelists.
Thank you. My name is Kai-Fu Lee. I'm a venture capitalist from China. We make investments in China and the United States, and about half of our investments are in artificial intelligence. So you've heard about the research aspect of AI, but I want to share that from a productization of AI, that's really the age that we're entering. Even if we freeze all the AI research right now, the existing technologies that are known to us turned into products applied to many domains will generate a phenomenal amount of value for mankind. So as a venture capitalist or as a large company that can harness these technologies and make money and build value from them, this is the golden age of AI. Now, of course, with the research, things will go even faster. The first picture shows from my company, Sinovation Ventures, what we see about the 4 waves of AI. They're not stages. They all happen together, not some earlier than others, but they're not sequential. The first wave can be considered the internet data wave. That is, AI is driven by data. The more data you have, the better off you are. And the first set of people who got huge amounts of data from us are the internet companies. Not only did we become data contributors, we became free data labelers. Every time you clicked on an Amazon result or a Google result, you're giving them training data to make their AI stronger. And that made them the first powerhouses in AI. In the US, that's Amazon, Microsoft, Facebook, Google. In China, it's Baidu, Tencent, Alibaba. And there are many more companies coming that way, building consumer internet applications, mining the data, and doing essentially big data AI to create a lot of value. That wave is happening right now, still very strongly. Probably the largest legacy that we'll know is that it has created these giant internet behemoths that may end up becoming monopolists or very powerful companies that will make it difficult for startups and professors. The second wave is the wave of commercial data. That is, companies like banks and insurance and hospitals have accumulated records, digital records, for the purpose of archiving or illegal reasons. Now they're sitting on a data mine, and that can be used for medical diagnosis, credit fraud, and so on and so forth. And that's a huge area that's emerging now. The third is, what about people who don't have digital data? Can they collect it and create applications that were not in place before? So Amazon Echo is in your living rooms collecting data right now. That wasn't possible 3 years ago. And as are the cameras in the shopping malls, airports, and so on, collecting data. And all that data can be built for smart home, intelligent traffic, smart city, the brain of a new city, and so on. That will revolutionize a lot of things. And then lastly is the full automation, robotics and autonomous vehicles. You've heard enough about that in the press. I won't go into it. They're increasing in difficulty, but they're all going to happen. Now, if we switch gears to the topic of today, that is the future of work, the first wave isn't much about work replacement. It's largely a productivity and something we enjoy as internet apps and websites. But the second wave will replace a lot of white-collar workers in legal, finance, and so on. And the third wave will replace even more people, and then the fourth wave will replace the blue-collar workforce. In my opinion, the white-collar workforce actually gets challenged first, the blue-collar later, different from what you see from a lot of industry reports. So let's make that practical. What really happens, let's look at the right side, for example. Those are 3 portfolio companies that we fund. So I'm not talking out of theory or anything, or not out of theory, but in real practice. So the first company we fund on this list is called Face++. You may have seen earlier this week, they obtained $460 million in funding, not valuation, but funding, because they have a massive amount of data that's making them probably the best face recognition, and in fact, human and gesture recognition and tracking company in the world. In reality, they are replacing security guard, front desks, and some work of the police by deploying this. The accuracy of tracking down criminals have gone dramatically up with cameras being deployed in places like airports. They can recognize 3 million faces simultaneously, pretty much the database everyone wanted on Interpol, and there will be no more 911 if this were deployed broadly. Obviously, some privacy issues can not subject to this discussion. The second one is an eBot, which is a customer service replacement, basically a deep learning algorithm plus a search engine applied to answer questions for a company to its customers. It's replacing tens of thousands of customer service reps. The third one is a credit, basically loan approval officer. It's for smaller loans. So actually, there are no officers doing smaller loans, but this algorithm will apply to bigger loans. And they're equivalently doing the work of tens of thousands of loan officers. So this job replacement is happening now, and it's happening in a true, complete decimation. This is not a replacement of work. Many optimists say that when tech revolutions come, jobs will go, jobs will come. Like on the left side, you see that in the Industrial Revolution, artisan jobs became assembly line jobs. So naturally, jobs were lost, jobs were gained. But on the right-hand example, the jobs are completed and gone completely. So while there are cases where new jobs will be created, I'd say that's the exception. And we have to somehow, as mankind, deal with this massive decimation of jobs over the next 10 to 15 years. My views, I'll go over it quickly, and then maybe can talk more about it. One is a lot of people talk about UBI. I think eradicating poverty is our responsibility. Giving everybody $20,000 might be overdoing it. Reinventing education, because we'll find that the jobs that are clearly not replaceable are of two kinds. One is creative job, and the other is social service jobs of love. Because machines, AIs, as we project forward, cannot yet create anything out of nothing. And that creativity, whether scientific, artistic, or storytelling, are for people. And we need to find talent and train them and hone our education to make those people learn the skill set they need to change the world. Because the value of each country will be measured by the percentage of creatives they have, not by the size of the population. The size of a population may become a liability, in fact. The third category is, what about all the people who are displaced? What job will they do and can they do? I think it's hard to train someone from an assembly line to become a rocket scientist. But one could consider service jobs, jobs that touch people, jobs that help people, tourist guides, concierge, even jobs like just talking to people, taking care of older people, taking them to hospitals. These are jobs I think we have to create, and I don't think they'll come simply out of corporate retraining its staff. Companies will downsize, people will be gone, and we have to figure out as governments and as socially responsible people to help move them to a service level profession and change our work ethic today, which is largely simply described as, if we work really hard, even if it's a routine, trivial job, we can get respect, dignity, and wealth. And that's what we want in life. That work ethic is just wrong, because if we hold on to that work ethic as our work is replaced, what will happen to the sense of actualization of the people whose jobs are gone? So I think we really have to think about how that can evolve. So overall, I believe we'll end up as human beings in a smaller circle of creative jobs, in a much larger circle of social or caring jobs, using tasks AI created, and that's how we might be able to coexist with AI. Thank you.
Thank you. My name is James Manyika. I think as you've heard for most of the talks today, I'm going to draw, by the way, on work that my colleagues and I do, quite frankly, with the help of some people in this room. I can actually see some of them in this room, and Andy and Erica among them. I'm going to talk about a couple things. I think, first of all, it's already very clear from the talks you've heard today that we've made amazing progress in AI, or autonomous systems, and robotics. In fact, we've made more progress than I ever imagined 20 years ago when I did my research in AI and robotics. The second thing that we've also heard, and I think Eric touched upon it, is that for the most part, this is actually brings huge benefits to businesses. We spend a lot of time working with companies and looking at all kinds of use cases, and undoubtedly, there's a plethora of use cases and applications that are going to enhance business performance, ability of businesses to predict, and so forth. It's also good for the economy in the sense that much of the productivity gains come from using and harnessing the power of these technologies and autonomous systems to contribute to productivity growth, which also contributes to economic growth. So good for businesses, good for the economy in that sense, and I think also good for society in the sense that a lot of these techniques are now making it possible for us to address and solve, if you like, societal moonshots. We're going to make a lot of progress in climate science, in healthcare, harnessing the power of these technologies. But I think the question on most people's minds these days is, what about work? As kind of the question. So this is all good for the economy, for business. What about work? We spent a fair amount of time looking at this question, and what we've done is taken almost a task activity level view of this. In the US economy, the BLS typically categorizes something like 828 occupation categories. There's data sets available out there, ONET being one, and a few others that capture something like over 2,000 activities. So we know what people actually do in those occupations. There's something like 18 or so different capabilities where you'd want to think about whether machines can do these things or not. They range from sensory activities to perception, cognitive tasks, but also physical, gross and motor skills and so forth. When you put all that together and try and understand how much of that will actually affect and impact activities that are done in the economy? What you come up with is something like this. At least that's what we came up with. This is based on what current technologies can do, and we put the activities here in roughly 8 categories. What you see is that the activities over to the right that are in the blue are the kind of categories of activities that are most easily automatable with today's currently demonstrated technologies, either technologies that are in labs at MIT and other places, or actual products. What you'll see, and those 3 categories are activities that involve collecting data in some form or fashion, processing data in some form or fashion, making sense of it, as well as physical work in highly structured environments. Turns out robots actually work pretty well when they're in very structured, lighting controlled, things laid out exactly what you want them to be, and so forth. Those activities on the right turn out to be a big chunk of what people actually do in the economy today. They make up, 51%, this is US data, of what people actually do in the economy and what they get paid to do. The things over on the left in the orange, brown colors are the things that, at least for now, are harder to automate. So we already start to see that a big part of what people do could be automatable. This is just a fun chart. These are all, the dots here show occupations, and they indicate the proportion. So the higher up you are on the vertical scale is an indication of what proportion of your activities are technically easy to automate. If you're lower down, it means it's harder. A smaller proportion of what you do is easy to automate. And it's actually quite interesting where you see some activities. File clerks tend to be higher up on the scale because a lot of what they do is mostly computational in a very structured and highly easy to automate environment, fairly routine to some extent. Although you see that, for example, I think Kai-Fu made this point, people doing landscaping, groundskeeping work are much lower down because it turns out that even though we've made progress with physical robots that can operate in physical environments, that's still relatively harder to do. And by the way, these are typically people working in highly unstructured environments, so much harder to do. For fun, we thought we'd show where CEO was. But you start to see that there's an interesting view here as to what could be automated. The other point I'd like to make is this one, which is in some ways perhaps a bigger point. When we look at occupations and try to understand, so which occupations have close to most of their activities easily automatable? Turns out there's actually a relatively small number, at least based on today's technology. It's about 5% of the occupations. But if you look at the other side of this, you suddenly realize that something like 60% of occupations have something like a third of their activities that are easy to automate. So what you then realize is that many more jobs are probably going to change than go away as people start to work alongside machines. And that's actually a bigger phenomenon. In fact, it's already happening today. Think about how any of our jobs have changed. And we're probably going to see even more of that as you kind of see the cognitive augmentation that Erik was talking about. So this question of jobs lost, but also jobs changed, is an important part of how to think about this question of the impact on work. So the question that ends up on everybody's mind then is therefore, okay, so with all this change between some jobs lost, jobs changed, maybe even jobs gained, because of course, part of what's going to happen is that some of the new categories are going to get created. In fact, we know that if you take any period, it's what Dick Cooper at Harvard called the other. The fastest growing category of work, of occupations, tend to be the other category, which are the occupations we didn't know about that keep growing and getting created every single time. So if you looked at the rows, that's usually so you're going to have some jobs lost, some jobs changed, and some jobs changed. So where does this all net out? Well, rather than try and make a prediction, there are a couple of scenarios that are worth thinking about. The first one is, a lot of this obviously depends on the rate and extent of adoption of these techniques into what people actually do. And by the way, a lot of what I just showed you is largely trying to answer the question about technical feasibility of automation. We know that that's not the only factor that matters. In addition to technical feasibility, you have to take into account the cost of deploying these technologies. You have to take into account how that plays into the labor markets and what wage structures are. So if you're trying to automate, for example, somebody who earns an occupation where the wages for that are $8 an hour, that's going to be much steeper than if you're trying to automate somebody whose average wages are, say, $40 an hour. So you have to take into account the labor quality and supply. So you have to take that into account. You also have to take into account factors like social acceptance. And we know that, in fact, some work that's been done here at MIT in the Media Lab also points to the fact that cultural acceptance of automation systems is actually quite varies across domains and application areas. We know that many of us who've ridden in driverless cars, the scariest things when you sit in that car in Mountain View and you see the empty driver's seat and this thing is going at 50 miles an hour, that's actually quite terrifying. Whereas most of us are quite happy to fly in a plane when we don't know what's going on behind the cockpit door. In fact, we know that pilots rarely fly the planes these days, but because we don't see it, we're okay with it. So these questions about social acceptance are a big part. So we have to see how this all plays out. But so rate of adoption is one question. The other question, of course, is the rate at which the economy grows, drives demand for more work. So where this all nets out tends to determine what happens. We know that at least there's one scenario up in the top where one of the, this is a scenario in which if we embrace these technologies, the good thing about that, it actually drives and contributes to economic growth, which also contributes to creating new jobs and work. But we also know that in that scenario where we're embracing these technologies, it's probably going to lead to higher rates of churn and change in the nature of work. But that's one quadrant you could imagine. Another one you could imagine is a case in which the economy doesn't grow very much and demand for work actually stagnates or slows down, but we actually adopt all these technologies. That's perhaps a more worrisome future where you might imagine, if you like, jobless productivity, where we might actually have net job growth be low, but in fact we're getting the productivity efficiency benefits from these technologies. There's also another somewhat worrying scenario, which is in a case where we have much slower adoption of these technologies, which also then which slows down, if you like, the contributions to productivity and also which in turn lead to slower economic growth. But you could imagine in that world where there are more jobs available because we're moving through this much slower, but those jobs will tend to be, the churn is lower, but you might then start to worry about the nature of incomes, the nature of wages, what happens in a relatively slow growth economy and has all these other issues. Then of course there's a scenario in which we don't adopt these technologies at all. The economies don't grow at all, and you kind of have circular stagnation. So I think we can have a long debate about where we think we ought to end up and what should happen. But what we do know for sure are a couple of things. We know that the mix of work and occupations are going to change. We know that with the adoption of these technologies, there's categories of work that actually are very large in the economy today, that in fact, over time, they're likely to decline in terms of the share of them in the economy, and others, and I think Kai-Fu made this point, that are likely to grow. So we have to think about what that means as the occupation mix changes. We also have to think about the implications on skill and educational requirements, both because of the changing nature of mix of occupations, but also in terms of this idea of jobs changing. And then finally, we also have to think about what kind of educational requirements are going to be needed. We know that in advanced economies, it's quite likely that, in fact, the entry-level requirements are actually going to grow, are going to increase. So the kinds of jobs where we're going to need more people with higher levels of education and skills are only going to go up. Whereas in developing economies, you actually have a slightly different picture, but that's a story for another time. Let me stop at that point. Actually, let me skip a couple.
Thank you. So this is a great segue to what I want to talk about. So I'm from Thomson Reuters, and I look after our R&D and AI. And one of the things we do, we're one of the second wave companies. We are in the commercial data business. But one of the things we look a lot at is how is work changing for knowledge workers. So we sell data to in the financial industry. We serve lawyers, accountants, people that are broadly in this knowledge work category. And I think the conversation around automation might be missing a nuance that's really important, which is the idea of providing cognitive augmentation for people. So we think about how do you take a lawyer and give him superpower. And I think if you look at that equation, then maybe the conversation around the future of work might be very different. So in our case, some of the things we are looking at quite a bit is advance in AI. creating more sophisticated solutions like building massive knowledge graphs, which my team has been working on. But really, the part I wanted to talk about here is that we've talked a lot about the demonstrated technology. So we have a great algorithm that can play Atari. That's awesome. In fact, I work with lots of universities, from University of Toronto to MIT to University of Waterloo to various things we see in the laboratory that is awesome. In fact, you can predict the likelihood that queries of humans can tell better than the CDC if there is a flu outbreak. Well, it turns out that demonstrating the technology is awesome and exciting. Getting it to the point where it becomes part of the way humans are augmented is a big leap. And I want to talk a little bit about that, since in my world, we have to go beyond the demonstration and actually make the thing work and be part of a tool. So one of the tools I wanted to describe here is, so Thomson Reuters has an army of brilliant journalists working around the world. And one of the things we did for them is figure out how to give them superpower. It turns out there is a problem called fake news that is kind of a big deal in the US these days. And one of the things that journalists have been doing, if you look at their workflow, is understand when there is breaking news by looking at social media. Well, it turns out that working with them, understanding the way they work, we've been able to use machine learning to give them a tool that is better than the human to help them identify breaking news in social media, and at the same time, basically a system in identifying fake news from breaking news. So the journalist is still there, but he has better power, superpower. And I think that's the kind of example of things we're working for lawyers, for accountants, for financial advisors, and so on. So what I wanted to talk about, and something I've been thinking a lot about, is a few heuristics. Being an MIT alumni, I think about systems a lot. And so I wanted to talk a little bit about what I think AI is doing if you think about the firm. And I think AI is changing the architecture of the firm. So yes, technology development gives us the ability to answer great questions we couldn't answer otherwise. And because we have big data now, and we have this stronger, smarter compute power and lower storage cost, we can bring lots of noisy data and look at what it does in algorithm and answer those questions. That's really awesome. The thing is, there's a big leap between the art of the possible demonstration, the thing that gets us an awesome academic paper that gets the guys in my R&D lab really excited, to something that actually gives superpower to a lawyer over and over again. That is a big leap. And there is a reason why this is not happening, is that I think somewhere along the line, we forgot about this thing called industrial process control. Okay, so you hire a bunch of really smart AI researchers, but somewhere you have to monitor the data, monitor what's changed in the system, what are the characteristics of the data, model it, understand what's happening, is your model as performant as it used to be, and basically create a whole new category of quality control in the organization, in the manufacturing plant, in the operations operations folks that are running all those things. And that, I don't think, when I talk to a lot of companies, is still front in mind. In fact, I don't know how many job descriptions say something different than, I'm looking for this awesome rock star data science unicorn, and actually says, I'm looking for someone who sits there and establishes industrial process control for modeling the data, validating that the parameters haven't changed, and if they've changed, what the consequences are on the performance of the model. I haven't seen a lot of those job descriptions, but my prediction is they're coming, because we are going to we see so much value from AI that we want to turn it into a day-to-day superpower. And the other piece, which of course is exciting research for my colleagues at the Sloan School and other business school, is that the architecture of the firm has to change. There are going to be perhaps paradox and different pulls and pull between a business goal and running the appropriate experiment to be able to collect sufficient data to validate that the model still works. That is a very different thing. If you're doing agile and constantly rewriting your code, that might be a different behavior to say, sit still, collect 3 weeks of data, feed the algorithm, and do nothing. Really? Do nothing? That's agile? That's really weird. How do I do that? Product management skills. How do you explain to our product management how to design and sell AI products? What's happening to business model? What's happening to pricing of information goods as you're starting to deploy AI? What are the expectations of your customers if they're used to highly customized features, and now you're saying, you know what, let the machine make all those decisions. So there is, I think, in order to get adoption, real value, augmentation of cognitive power for humans, it's not only the technology, it's really thinking about its maturing and operationalization, and how is the firm changing in order to make that happen. Thanks.
So this is great. We don't have complete consensus. But let's start with our title, the AI Revolution, Why Now? What it means and how to realize the potential. So Erik, why now?
Well, that's a great question. And the question is this time different? And what is different now? And I think that there are three really powerful trends that have come together that really are driving this revolution. The first, as Kai-Fu mentioned, is just a lot more data. And we have so much digital data now. 20 years ago, most data was analog. Think of photographs or most of the other things. And that's the lifeblood, that's the driver of these new machine learning systems. The second thing is vastly more computer power. The computers today are hundreds of times more powerful than they were a few decades ago. We did the arithmetic, and some of the systems that now figure out voice recognition, if you ran them on 1990s vintage computers, they would have taken 250 years to run. So we have not just Moore's Law, but new processing chips like TPUs. And then last but not least is incredible improvements in some of the basic algorithms. People like Yann LeCun and Jeff Hinton and others have made some breakthroughs that allow us to use these technologies more effectively. So when you put those together, there's been roughly, in some categories, about a million-fold improvement between the vast increase in data availability, the more computational power, and the better algorithms. So, for instance, recognizing pedestrians for self-driving cars, that is about 1 million times more accurate than it was in some of the early systems. And I'm very optimistic that this trend will continue to accelerate. Kai-Fu and James both talked about what would happen if we just froze technology and used today's automation technologies, and all the jobs and the economy would be affected. And I agree with what they were saying. But of course, the technology is not frozen. I think that those three trends I just mentioned are not stopping with the Internet of Things and continued progress in computers and new architectures. And of course, far more people going into the field. There are 10 times, if you look at the charts of people going into AI research, it's almost an exponential trend itself. And each of them are inventing new ways of using the technology.
So let's stay on this theme a little bit longer. Kai-Fu, let me push back just a little bit. We've had integrated circuits for 70 years. We've had microprocessors for 60 years. To take a question from David Otter, an MIT labor economist, why are there still so many jobs now?
Well, the current generation of GPU plus CPU is, as Erik said, so much more powerful than during the days when I was doing my PhD, right? I thought Erik was talking about me. That it literally took us several days to recognize one sentence of speech. So,
you were doing that 250
I was
years.
yes. And in fact, I think back then it was impossible to do the experiments that are being done now with the massive amounts of data and training. And that's just with the data that we can collect and use. There's a lot of applications we don't yet think about that will further push this out. Imagine, I think the computation will probably increase another 1 million times in just the next few years with all the applications we can't imagine. Not that the CPUs will get faster, but their proliferation. All of our phones will be able to do deep learning. Our traffic lights will be hooked up. As an example, recently in China, one company basically put cameras to see what cars were going where, and use that to modulate the traffic lights. And the time to destination was reduced 15% for the drivers on the road during busy hours. So and that kind of application, you can imagine, needs all kinds of sensors on cars, roads, everywhere. So the age of IoT will come, and that level of computing will be even 1 million times more than now. And we're 1 million times more than when I did my thesis. So I think the computation problem will be solved.
James, let me ask you just a little bit about task automation. So James Besson at Boston University has done a fascinating piece of research where he points out that there's actually a positive correlation in these SIC codes between the degree of automation and the rate of job growth, which is totally counterintuitive. Did you find that in your research, and does it mean if we're automating tasks that actually the number of jobs will grow overall?
So short answer is yes, that correlation is actually the case. And I think the reason why, to David Otter's question about why they still work, I think there's at least 2 or 3 reasons I can think of. One is the fact that economies grow. And there's always a level of dynamism and new job creation and shifts. Think about what happened when people moved from agriculture to manufacturing and then now to the service economy. So we're always creating new occupations and new jobs. The other thing to keep in mind is that it's one thing to talk about technical feasibility. It's quite another to think about the economics and deployment and how this plays out in the labor markets. One way to think about that as an example is think about the electric car. When did we demonstrate it was technically feasible to build an electric vehicle? 4 or 5 decades ago. When did they actually show up on the street? A decade or less ago. Because what happened between those 2 points was we needed to build systems that actually worked and within certain cost parameters and certain performance parameters. And there's all these kind of replacement questions and rates that kick into the pace of adoption. So when you talk about the rate at which the technologies are going to be adopted and become pervasive, that's actually much slower than the rate of technical feasibility to do these tasks. So that's actually one reason. But to your point about tasks is, as I said, one of the things that's interesting is that, there are going to be fewer instances where we're automating entire jobs relative to partial automation. And we know that when people work alongside machines, often magic happens. There's higher productivity, but that also raises the skill requirements. And so to the extent that we can up the skill requirements and, in fact, create demand for work, we will create jobs. I'm actually less worried about will there be enough work. I'm worried about other things. I'm worried about the skill gaps and the transitions and how we deal with that, and I worry about the income effects. But I'm less worried about the will there be enough jobs question.
Eric, quickly, and then I have a question for
Well, I just want to push back on the premise of that question a little bit. Yes, there are lots of jobs created, but as I showed in that chart, they weren't necessarily good jobs. And so a lot of the median income actually has been falling. So there have been a lot of people struggling. It's not like it's been great over the past 40 years. And even you go back to the 1800s, people say, well, we survived that industry. There was this period of about 30 or 40 years, Engels' pause, some people call it, where wages did not rise, and there was, near revolution, or was revolution in some countries. So this is not at all automatic in the past, and this time around, I think, as we've just heard, there are some even bigger waves happening. So I don't think we should be at all complacent about what could happen. Well, I want to stress, though, that both in the 1800s and more recently, there are things you can do in terms of education, entrepreneurship, and other things that drive new job creation and drive wage growth. But this is not something that just automatically works itself out, and that would not be the way I would read history.
So how dark are you about this? There were those who argued the middle drops out, but there's growth at the top and bottom. But then there's been recently research that shows that perhaps we're on a sliding scale, and the only place that we're really getting growth is at the bottom. Is it that serious to you?
It is, and it is exactly that serious. And some of these technologies that are affecting radiologists and maybe college professors, I don't know, CEOs seem to be somewhat immune, I'm not sure. There's a lot of high-end jobs that will be more and more affected. Kai-Fu and I were talking earlier that a lot of white-collar jobs are going to be more affected than in the past. But I also want to stress that there's not a technological determinism that drives this. Yes. I'm glad that James put up that 2x2 with the different scenarios. We have a lot of choice as to whether we end up in that upper right quadrant, or I think most of us want to be. And I don't think we're making the right policy choices. I think it's wonderful that these technologies are giving us some options, but it's up to us to decide where we want to be on using those technologies.
Okay. Mona, so have you had enough experience inside Reuters Thomson to see what the job consequences of deploying machine learning are? What does it look like inside?
So I think this is the point I was trying to make, is that if you look at augmenting the process of running a financial audit as a tax auditor, for instance, there are a couple of scenarios. I think the economics of it needs to be studied, right? So I'm really excited that your colleague Josh Gans is starting to look at this stuff, We can see you can give superpower to a knowledge worker. The question is, when do you get to a place where the economics of it change, where you might need 10 lawyers and not 20 to do the work because they're augmented? Or do you then have the same 20 lawyers that are now super effective because they can use predictive analytics to figure out how to prepare for their litigation, and that the economics of their relationship with the customers is such that there isn't a demand for them to be like. So it's, I think, a bit too early to figure out how that plays out, at least in the knowledge worker area. But the thing that is clear is that a basis for competitive advantage is to add AI-enabled cognitive augmentation for those jobs.
So a quick comment on your tracker.
Yes.
So if you can identify news in social media, why not take people out of the loop? You're in a competitive business. Why keep the humans in the loop?
Because it's not at the point, if we can detect breaking news, but it's not to the point where we can do the analysis and really take the story. So this is essentially an alert system for the journalist. As you know, there is machine-generated news for the very simple stuff. So what that does is it enables our journalists to focus their time on the part they're really good at.
What are some of the simple sorts of news stories that are done automatically?
I mean, they're happening, for financial reporting. Those are happening automatically. I mean, anything that's very structured can be natural language generated, which I think is really good news for journalists, right? Because we're really relying on their expertise. So the main thing here is AI alone doesn't exist. It's the domain expertise that really brings the right question for creating the augmentation and actually provides the domain expert the bandwidth to really think and be more creative and ask the right questions, and then also make the analysis that only today the humans can do.
So let me try to get our audience in. Mary Gray asks, could speakers talk more about the role paid workers play in both training data and doing, quote, quality control when AI gets stuck? What happens when the AIs fail?
So that's the point I was making, right? Which is that in order to have this technologies be industrial grade, there is a whole set of expertise required to monitor the quality of the data, the condition in the system in which the data is collected, characterize it, model it, and then those don't necessarily need to be rocket scientists, but there's a whole set of essentially what we used to do in manufacturing, right? Like the way we went from used to be that every other car may have been terrible, and then Toyota brought in system control and lean and so on. It's that sort of discipline is going to create a set of jobs that may not be here. It might be evident for all the first wave you described, the digital native company, but if you're in the business of building tractors and you have lots of sensors, you may not have in your factory people who are expert in understanding how do I monitor the sensor data in order to build AI-enabled solutions.
We're down to our last minute. Quick, Kai-Fu?
So AI doesn't fail. AI fails a lot less than people. In the 3 examples I gave, the AI loan officers are much, much better than human loan officers in terms of bad loans. The face recognition algorithms are much, much better than people. So yes, they will fail occasionally. And when they fail, there will be an outcome that can turn into training data to make it better. So let's say you let someone into the country that you shouldn't have. They were a terrorist. They got arrested. That data will come back to train and say, OK, next time I'll do better. Say you gave a loan and someone didn't repay. That data will come back to train. So AI will keep it getting better, unlike people.
But you need a human to identify the new data set. Today, the machine cannot find the wrong data set.
In these 2 applications, you do not, because it's the outcome driven.
My watch is buzzing. We are
whether a human thinks you're a good loan or a good risk is not relevant. Whether you repay or not is what's relevant.
So thank our panel, and we're going to take a quick 5-minute break, and we'll be back to try to get a little bit back on time this morning. Thank you. That went fast.